ми робимо, як правило, заходи. Я не знаю, хтось вперше є сьогодні? Great. Ну, значить, ви всі знаєте. Так, наші заходи безкоштовні, атмосфера домашня, і якщо ви прям переживаєте, що вас зараз засвистають і закидають помідорами, що ай-яй-яй, ви таку фігню розказуєте, то ні, такого не буде. І ну, хто бачив відео наших ранніх виступів, гірше не буде, не переживайте. Тому зголошуйтеся, насправді, чим більш ви активні, в будь-який момент до нас можна долучитись, писати статті, допомагати організовувати івенти, ми всі відкриті, нема такого, що вхід по знайомству і тільки для наближених осіб. Тобто будь-хто хоче допомагати організовувати ці івенти з великою радістю, тобто у нас завжди брак рук і тому так, ми були б дуже раді. Окей, я думаю, що у нас вже 2/3 місць зайнято, і Гжегош вже давно готовий. У нього взагалі є думка, що ми пізно починаємо, тому всі пізно приходять і кажуть, що треба починати вчасно. Наступний раз ми спробуємо зробити все вчасно і перевіримо, чи це спрацює. Окей, so, Grzegorz, I think it's your time. Welcome, Grzegorz. He came from Poland to Ukraine. It's not the first time, actually. I think you know. I have a small present for you. Welcome back. So, meet Grzegorz.
First question, do you hear me without microphone, or should I let it? No. It's fine if I don't use microphone? Better use. It's too quiet. Okay. Now better. Okay. So, hello everyone. I'm very happy to be here. I mean, last time I was in Lviv, actually, I think it was February. I really enjoyed coming to this beautiful city. This talk, well, since we are on a JUG, it's very like informal meeting, so remember that you can always ask questions on the spot, because we are not really bounded by any like conference 45 minutes format. So today we'll be talking basically about exception, and another approach to exception known from the world of functional programming. Of course, this is not maybe those are not solutions that you will always benefit from, because silver bullets do not exist. But I hope I can show you some new ideas that you can experiment with and adapt to your own systems, programs, and solutions. So, my name is Grzegorz Piwowarek. I'm from Poland, Warsaw. I'm a simple developer. I'm an open source committer. I've had my commits to Waiver or Java slang or AsserJ. Recently I started blogging at For Comprehension, and since like a year I've been helping Eugene Parashuk with running his like Baldwin site. So I'd like to start. So basically, when it comes to exceptions in Java, I can. Okay. So when it comes to exception in Java, well, they've been like, there are some disadvantages of them. People have been complaining about them, well, for quite some time. Well, this is not only about exceptions in Java, but exceptions in general. So for example, runtime exceptions are often not visible in the source code if you don't cache them on the spot, and they can fly all around your code in unexpected places. And create unexpected exit points from your functions. Because, well, if your function can throw an exception, you need to think about it as, well, one of the possible return types. And if you don't really, well, control it in which place is it actually, well, it can like pop up, it becomes problematic. Another problem is that basically the whole like try-catch thing is slightly kind of like a go-to. So you throw an exception, catch it, you jump somewhere else to handle it, you go back. Well, maybe you re-throw an exception, you jump somewhere else, and it's pretty unpredictable. Well, another problem is that when you are playing with asynchronous computation and you try to use exceptions, well, in the past there was quite a lot of problem, because, well, if the exception is thrown, it might get lost in a thread. Now it's slightly easier, but it could be problematic. And as you can see, this was noticed, for example, well, quite a long time ago. For example, by Grzegorz Piwowarek. Grzegorz Piwowarek is the guy behind Trello and Stack Overflow. So I think it's 2003 when they realized that something is wrong with exceptions. Of course, they solve certain certain situations, but they generate their own problems. So when it comes to the critique of exceptions in Java, there are mostly 3 points that I'd like to point you at. The first thing is the absence modeling. Often when you are trying to, let's say, imagine that your functions, methods are returning a collection of things. So sometimes in such situations, we can find code that throws an exception, no such element exception. So it's used for absence modeling, and this can be problematic because by throwing an exception, you kind of enforce users to process it in a certain way. Another thing is that since we have exceptions, we tend to often model unknown business cases, which is basically kind of similar to the previous situation, where we know that there's for example, our logic can divide, go into 2 different directions, but it's often you can see that we are using exceptions for this thing. Same with basically modeling alternate paths. And the interesting thing is that exceptions are slightly more expensive to create than normal modules. And do you have any idea why is that? Anyone?
Because they give stack trace.
Yeah, exactly. So exceptions are not normal modules, okay? There is some certain cost associated with instantiating them. There is one, and the problem is the method that fills in the stack trace. Because essentially, you just need to go over, you need to traverse the whole stack and collect your frames and have a look and stash what's inside. So there is one guy that made a very interesting comparison. I forgot his name, but he's responsible for NetT, and he was playing with, experimenting with doing benchmarks on exceptions. And he noticed that, he was comparing 3 different situations. The first one was classic exception instantiating and throwing. And on the other side of the coin, there was a case where we would create just one static exception, and without a stack, we stack traceless. And the improvement when it comes to performance was significant. On the left-hand side, you can see, let me show the numbers. It's less than 1 operation per second, and on the right you have over 60. So the improvement was quite a bit. Some of you might say that JDK actually has something internally, is performing some caching for exceptions. Unfortunately, this is the case only for exceptions that are known to JDK. So if you create your own, it won't be optimized. This is what they used when they were creating the NetT. I'm not telling you should do this every day in your code, but it's something that is very worth to be aware of. That it's not only sometimes cumbersome to handle exceptions, but often can take, there might be a noticeable performance impact for doing this. So, over the years, there have been multiple practices considered as anti-patterns in the world of exceptions. There's quite a lot of them. Obviously, some of them, everything depends on the context. Some situations, some solutions are the only way to go. But, exceptions solved some problems, but created another one that we needed to deal with. And I'd like to show you some different approach that maybe would not create that many cases. So, for example, one language I've been playing with is Go. Go has a very interesting approach to exception handling, in exceptions in general. Basically, it doesn't have exception at all. There is something like errors, and those are normal plain objects. There is nothing special to it. So there is no additional cost associated with, throwing them, because you don't throw them, you don't catch them, so normal objects. And the way it's being returned from functions is that functions can literally return more than one type. So each function can return the declared value, but it can also return another type, which is an error. And the way you handle this, actually, it's not the nicest thing that you hope to see here, a null check. But still, there are some advantages of this. Because if there is no exceptions thrown in different, if you imagine functions or methods as like basically pipes, in Java they can basically leak all over the place. Exceptions can be thrown in different spots. But here, basically, if you think of this as a pipe, and if you have your returns, well, if your function returns a normal return type and an exception, well, an error object, it becomes much easier because you can pretty much like, if you observe like the end of the pipe and just check for an error or an exception, and if you actually, it's not there, you are sure that it wasn't from anywhere before. So in this way, surely you can write much more predictable code using this approach. Well, double check is kind of ugly, but this is like slightly lower level language than Java is. But of course, sometimes there are situations in our code where we need to signalize that something is going wrong. So obviously, Go has something like panic keyword, but this one is designed to be used only in situations where well, we are actually panicking. Okay, so for example, imagine that we are modeling, well, a bus stop and buses arriving there. So okay, we go on a bus stop. Well, often in Java code on GitHub, you can see that people would model like the case where bus arrives, well, and it, for example, is empty. They would throw an exception. Bus would not arrive. They would throw another exception. But are those really like cases where we need to use exceptions? Are those really exceptional, or this is like something that's kind of expected, and we shouldn't like enforce like special treatment to this? So, well, obviously this is like relative, you know. Well, sometimes when bus doesn't arrive, well, it's exceptional. Maybe in Switzerland, okay, if their buses are late 5 minutes, or trains, they just go on speakers and just say sorry to everyone. But in Poland, sometimes trains don't arrive, and it's not. So of course you can kind of like of course you can like recover from a panic in Go by using the first method, but this is reserved mainly for situations where we don't expect exceptions to be caught. And this is actually a very good use case for exceptions that we have in Java. If we throw them and don't really expect anyone to catch that, that works great. So now we are in the world of Java, which is a strong statically typed language. So I think that most of you, if you are already writing Java on basically on JVM, you understand the advantages of having strong static typing. But let's kind of revise them a bit. So when it comes to static typing, the good thing is that obviously that we have the abstraction of types and we can model stuff using this. Personally, I think that this is, well, when we are playing with strong static typing is like, well, I feel the most comfortable in such situations. Well, because I know that if I model my domain or stuff properly, it will save me a lot of pain. Of course, it might be, well, kind of hard or irritating to like play with types all the time and sometimes write some boilerplate code, but still long term I value the things that I get when I'm doing this. So for example, if you recall, is anyone here a Scrum Master or like working with Scrum projects? Probably all of you, right? No? No one? Okay. Anyway, because recently I've seen like there was, for example, Uncle Bob. There was a famous Uncle Bob's post like 6 months ago when he was like bashing Swift and Kotlin for being too statically typed. But my personal approach is that when you are playing with, well, anyway, the idea was that it's bad because the static typing is trying to solve problems that should be normally solved by having a good test. Well, but when I'm running tests and something doesn't work, it's slightly too late because the feedback cycle that I have is much longer. If I can use my compiler to, like humiliate me a little bit earlier, if we can have those feedback cycles like shorter, we can much faster react to stuff. And obviously, if we are like protected using this type safe strong code, it will benefit us in the very long term. Obviously, it will be pain in the ass if we want to like prototype something very quickly. But if we are thinking about, well, not only developing something but also maintaining it over the years, this is something that's worth going for. But unfortunately, well, we are in this aesthetically typed world in Java, but what we often do is actually not strong typing, but stringly typing. So I bet you've seen multiple times that like DTOs, closures that, well, they contain mostly like strings, that all types are multiple. It doesn't matter if it's address, integer, phone number, anything else, it's always a string. Well, so this is not very strongly typed, so this doesn't save us. But if we apply like type-driven development approach, this is where the types save us. This is where type-driven development and static typing flourishes. And this is what we should basically, well, at least consider going for. Actually, since Java 8, well, Java started noticing that it has its strong type, and maybe it would be worth to actually start leveraging this. So, since if you have not been like living under the rock for like last 3.5 years, you know that, for example, in Java 8 you've got something like optionals, which is a great example of how type-driven development works. Because you take types and use them for representing, well, some computational context. So in this case, we use types for representing, basically, expressing optionality of our objects, and it's worked quite cool. Unfortunately, we have still nulls in Java, so well, they didn't work perfectly, but still, it was a nice improvement. So, are you all familiar with optionals and how Java 8 works mostly? I see most people nodding, so it's good. So let's go forward. So for example, if we can encapsulate, well, optionality using types, why not use the same approach, take it further? So in functional languages, well, Scala is not functional, it's functional, object functional. There are types are used for expressing many more things. So for example, in Scala, they introduced a tool called try, which is basically well, something that works similarly to optional, but it doesn't encapsulate optionality, but it encapsulates, well, everything that can throw an exception. So, as you can see, it looks like this. This is basically one class that has two subtypes, success and failure. So we are passing around basically our superclass that's called a try, but underneath it can be either failure or a success, and they all behave appropriately. Well, obviously, if we call something on success, it will work properly, but if we call something on a failure, it will not work. So this is how it looks like. Well, this is like one of the approaches that are being used in Scala. And for example, for Java, we have different libraries that have been implementing the same approach. There is one implementation by Jason Goodwin, I think it's called Better Than Java Monads, it contains try and other tools. But I think the one that's the worst, the best one to have a look at is the one implementation from JavaSlang, which is now called Waiver. So, unfortunately, in Java, the language is not that expressive as Scala. So, in Scala, this thing is modeled basically as a sealed class. Sealed class means that we have like strictly limited amount of implementations that we can provide for our type. So, if you have this try with success and a failure subtypes, if you put sealed on it, users won't be able to implement it provide their own implementation for try ourselves. In Java, there needs to be like some small hacks to do this, but it's possible to imitate this. In Waiver, they use interfaces for this, and it works. So let's see how it looks like in practice when we try to use this stuff. So in order to imagine how this would possibly work, let's have a look at the method, at the implementation of the method that instantiates try objects. So as you can see, it's not a magic. you can see inside, we provide the factory method with a checked supplier, or check function check supplier. And now we simply, we try to run it. If it throws an exception, we just return success. If it doesn't throw an exception, we return a success object with a value inside it. And if there was exception thrown, suddenly, we just return a failure. Of course, so now we have, our exceptions encapsulated, but it's not that cool yet. So the fun begins when you start developing APIs that are dedicated for exception handling. So if you know optionals and Java 8, you will see a lot of familiar methods, because those all ideas come from the world of functional programming, and this is kind of a standard. So we have methods like map, flat map, filter, and they are all everywhere. And it doesn't matter if it's Haskell, Java, Scala, or Kotlin. They all have the same name, which is cool because it's super intuitive. You take a new tool and you know basically how to use it because you see familiar methods that carry the same semantics as other languages. So the cool thing here is that we can now build quite a very rich API that allows us to deal with exceptions in a very, very easy way. So we are not throwing an exception at user. We can give user a try object, and now they have a choice. They can either, just call, for example, .get method that re-throws the exception. If they want, they can, just ignore the exception and provide default. Or they can perform, chain some additional method, chain some computations, and do something with the type, or even with the exception. Or maybe even try to recover from the whole situation, perform kind of like a fallback value that should be returned in case of something that's wrong. So it's super interesting because we have we get now we give users a choice to do different stuff in a very, very easy way. Actually, when it comes to try, it's a kind of it's kind of a workaround. It's something that doesn't really have place in a normal world of functional programming. But since we are working in Java and exceptions, normal exceptions are present there, they created something like somewhere between what we can find in, for example, Haskell and other languages. But it was essential so that we can we can adapt already existing methods that throw exceptions. So if we have a look now at try from the consumer side, consumers means is that we want, for example, call a method that instead of throwing an exception, returning a better result or null, just gives us a try object. So as you can see here, we have the first method called getSearchResults, and this is the old school way of doing it. Okay, so we have a search results that returns a list of URLs, but it throws an. Can you see this? I hope so. Okay, so it throws an exception. So this is, for example, the old school way that we would model such situation. Because obviously, it gets search results underneath, calls some, make some HTTP requests and collects some stuff. So at some point, it can throw IO exception. So if we adapt the new approach to this, we would not throw an exception in this case, but use try object. So in this case, the return type is the list of URLs. So we can package them into this our computational context of exception handling or try, because we already know how it's named. And now, if we are basically consumers, we are users of this method, of this API, as in the third row over there, we have, we call the method, and now we have a choice. So in this case, we decided to, let's say, call some method. If it's a failure, which in this case is simple logging, and then just return a default value if something went wrong. Because let's say we already know one of the addresses over there. This is how it looks from the consumer side. But if when we are implementing such methods, it looks slightly different. It's also quite easy. The API is quite flexible to make implementations easy. So let's have a look. In this case, in our method that's called getSearchResults, we use two internal methods. One is called getFromGoogle, and the second one is called getFromDuckDuckGo. The idea behind this is that we have different methods that behave differently. So get from Google throws no such element exception and IO exception. So as you can see, it informs us that something went wrong, like on the communication side, but also informs us that it didn't find anything for some reason by throwing an exception, which is not that easy to handle. And on the other hand, we have the other method, get from DuckDuckGo, that throws just an IO exception. And if we see the third example, here we are implementing our get search results. And as you can see, it's quite easy because the tries API is super composable. So here what we are doing is creating a try all and simply passing the get from Google method. But API is so flexible, we can define on the spot, for example, what to do in certain cases. So if there is no such relevant exception from, well, we know how to recover from it. Because if there are no found elements, well, that's essentially an empty list. So we can easily call recover and recover from it. Another case is that there might be some exception from that's not really defined. Okay? It's not objective search. It's a runtime exception we write in a documentation that is being thrown. So another recover call. This is NSA forbidden exception. Again, empty list. We know how to do, how to handle those. And finally, last one. If something went wrong still, and if those are not exception types that we know, we can use a fallback method and call another method. In this case, it's get from DuckDuckGo. So as you can see, the implementations are quite easy to write. It would be much harder to implement it by ourselves. So another thing that we can encounter here is, for example, as we have a situation like here. In this case, we are just getting a single search result. And let's say we get those results, we get a try object, but we still might want to do something with it, using map or our flat map. And in this case, we are calling an open stream on URL. We want to actually look up what's in there. And the problem is because open stream throws another exception. Well, we can use try catch here, which will be quite ugly, but we decided to use it. But we know we have try, which will be slightly easier. So we put this value again into try. And suddenly we have a problem. Because we got our try object to perform the map, where we returned another try. And we ended up with try from input stream, which is not perfect. Okay? Because whenever we end up with situations where we have multiple times nested like monads, like try or optionals, it doesn't give us anything. It's not like we, put try into try to try. It doesn't give us even more and more safety. It's more like a problem for us to handle. So it's good to remember that whenever we end up in possible situations where we might end up with nested structures, it's good to remember that there is something like flat map, which is especially designed for situations where to avoid nesting of those monolithic structures. Also, when we're talking about the beginning of showing those structures and mentioning sealed keyword, it's also super interesting because, if we know that our abstract class has super limited amount of implementation, our compiler can help us in certain situations. For example, when doing pattern matching in Scala. So if we forget let's say about some type, compiler will tell us that our pattern matching sequence is not exhaustive. In Java, we can't do this. We have waiver or Java slang that will help us, but obviously it won't work as good as pattern matching from Scala. But still, super interesting use cases when you have tried to use pattern matching and other stuff. So for example, if you don't want to use this composable API, you can use pattern matching and, for example, specify that, if you have a result, for success you want to do something, and for failure to do something else. So that's all when it comes to try. But what if we really want to try to simulate more like Go's field, okay? Because try is still dealing with exception, it might be throwing exception, but let's say that we really want this Go's field. Everything is super predictable when we just check for an error object and there is no exception so involved? Well, we can actually simulate this with tuples, but it's problematic because usually when we are working with tuples, there's assumption that those are usually rather non-nullable values inside. If those are nullable, it becomes super problematic because suddenly you need to perform huge amount of null checks. And in Go, null checks are, well, it's not as high level as Java, so this is quite acceptable, but we probably don't want them. So the question is there a solution for this? Yes, there is. So there's another concept, which is now comes from the pure functional programming, which is either. This is a tool which comes from the same family as optional tries and other stuff. Again, we have something that has basically some class, some monadic tool that can have two states, left and right this time. Optional is either present or not. Try can be success or failure. Either can be left or right. And what's super cool about either is that it doesn't tell us which side is, well, the right side. Not the right in terms of right or left, but which one is good and which one is bad. That allows us to apply it in many different scenarios. In optionals, for example, if we have a full optional with something inside, we call map filter, well, something happens. If we have an empty optional and call map filter, nothing happens. Those are just pretty much skipped. With either, and either is unbiased. So either left side or right one can be a good one, depending on what we actually do with it. And this allows us to either handle error objects, returning error objects and normal values in an easy way, or for example, handling situations where we end up going into different business logic paths. So as you can see here, again, in Scala, it's an abstract class, which is a sealed hierarchy. We have left and right. And one important thing, in Scala, since, I don't remember since which version, but since some version, there was a bias introduced to either. So the right one is kind of treated as an implicit success. But in Java, well, we don't have either, so we need to use external tools, rather construct them by ourselves. So in Waiver, what they did is they used the interface. They use interfaces because we can do some tricks with them. And well, we have left, right. Obviously, there is no sealed keyword, so no guarantee that someone will not implement either interface by themselves, unfortunately. So how does it look in practice? In practice, we can create either left instance or right instance. But still, we don't know which one is good and which one is bad. They are both equal at this point. But the very important concept comes in, the concept of either projection. So the best thing about either is that you can actually tell it which side for us is more important. Then we can create left or right projections. If we create right projections, whenever we call filter, map, or other stuff, it will work fine if we are operating the right value, and won't work if underlying value is actually left. Well, technically it should not compile even, because because those types of both sides probably are not compatible together. And whenever we create a projection, obviously we will have methods that it will operate on something of one type. So super handy. So obviously the API can be the best thing about this, that you can build a really nice fluent API. The one problem with either is that since it's very generic, we don't know the context. So it's not exception handling, it's not optionality, it's not something else. We can't create as specific methods as for the try, for example. So here we have very generic methods like by map that we can buy, where we map where we provide two lambdas that map both variants, either if it's left or right, or get or else, or all stuff like this. After creating a projection, we can, the API is not very predictable. We have maps, filters, but nothing really fancy like recover or other stuff known from Java. Because it's super generic and it's up to us how we use it. We can use it for exception, well, for returning error objects or whatever else we want. We just want to return 2 types from the function. Super cool. So, how does it look like? So, if you want to use either, well, for exception handling, we forget about exceptions in Java. We probably want to return error objects that will just give us some information about what happened. So, if you are playing with Scala or even with Kotlin recently, it's super easy because we just define an object that has, for example, some message and the response inside. Well, and this is just one line. But we are in Java, so we need to write slightly more code. Okay? So this is not very encouraging, but if we use something like Lombok, it's totally doable in much easier way. And now, how does it look like in practice? So again, let's look from the consumer side. Let's try to implement, redesign the method that we had a look at a few minutes ago. So we started with get search results. That at the beginning it would just throw an exception, but now it's just returning try with a list inside. So let's try to get rid of exceptions at all from this context, and we create another case. It's get search results, and this time it returns an either fetch error or list URL. And now, if we want to consume either, we need to use projection. So in this case, we are using the common strategy. The common strategy is to actually use right side to represent success, or like the happy path. So in this case, what we do is we just want to go through our desired result. So in this case, we need to create the right projection. So after creating a projection, we are operating on an either that's right biased, and now we can perform, work directly with our desired type. So now we can perform map, filter, and other known methods. And at the end, for example, use getter-else and other non-API processes. But in other case, let's say we want to be prepared for a situation when there's an error object in there. So now, in this case, we create, left projection, and again, perform some mappings, perform some operations on this value, and that's all. We are avoiding totally necessary null check, and end up with type-safe solution that allows us to easily handle, both cases of success and the failure, where in this case failure is presented by error objects. Of course, either is super generic, so we don't need to use it for exception handling only. So for example, imagine a situation where we are writing an internal method that is resolving some URLs using DNS. So whenever you basically call a DNS, you might either get a full response or might get an address of another DNS server that has a reminder part of the URL. So, that's can be totally fine implemented using either, just like you can see here. So on the left we have DNS URL, on the right URL, and basically in this case we don't consider neither of those sites are better. We have two different equal results that we can process. Also, the very interesting example of usages of either is internal class of Scala from tail calls class. And this is class that's basically resuming the tail call recurrency operation whenever needed. So as you can see, they use either to model the whole situation. Either, in this case, either you finish and have a ready response, or you just still perform and go with another tail call. Well, I don't expect you to understand this, but I want to show you that this is actually used. Okay, it's not something like that no one uses talks about, but actually, if you go through Scala, if you go through Scala sources, it's being used quite a lot. The problem is that sometimes when we mix libraries or other people's code that throws exceptions. And if we mix, for example, our approach with others, we might end up, well, unfortunately, with something that's quite unpredictable. Because on one hand, some people are throwing exceptions and we are using others. And so it's very important to have like a common agreement, reach a consensus how we are handling everything. And another thing is that, well, as I said before, exceptions are often abused. They are used too much. So for example, let's have a look at those two methods, like find one and value. Find one is the name for common, let's say, operation from Spring data repository or something. And if you browse GitHub, you'll see that many people just throw exceptions in the same situation. So, but do we actually need an exception in such a way? Okay, if there is no person present, okay, just like here, why throw an exception? This is kind of redundant because there are other ways of telling how to do it. Because, well, of course, when you throw an exception, you can add some additional info there. You can pass some metadata. But do we really need a stack trace? Well, with no such limited exceptions when there was something not found to the repository? I don't think it's very useful. So in such case, it might be much easier to just provide an optional, to use optional for absence modeling instead of throwing exceptions. And this is again super handy for people that consume them because suddenly they have a choice. If they want to have an exception, they can easily throw it. If they don't want it, well, they can leverage the nice functional API. Well, if they just want to rethrow some exception, it's also super easy. Same case, for example, with parsers. If you have, well, like here, the value of method from integer class, it throws number format exception. And if you ever played with that, for example, tried to parse a string, you see that this message doesn't really tell you anything interesting when this happens. So why force people to handle checked exception that looks like this and can be super unhandy in certain situations? Why not just pass an optional for this? So this is some design choice that you might think of, and well, you might want to apply that, might not. I prefer such an approach, but it's another idea worth considering. And if you actually look at GitHub and do very naive search, you will see that, well, I don't know if you can see this, but on the left we have search for throw new, no such limit exception, and around 600k results found. And on the right hand we have throw new not found exception, which is around 250k. For me, actually, it's very hard to imagine how many situations we need to have where we throw no such limit exception instead of just returning an optional. Obviously, there are use cases, but for 600k, I don't think so. I think those are just pretty much Java developers like accustomed to certain way of writing. Okay, so I did it often at the beginning. I remember that there was a lot of cases I would just mindlessly just create and throw an exception. Well, this could be avoided. And now, well, we are working with Java mostly, so we have a problem. What if language we are working with it doesn't support all those paradigms? Well, we can obviously switch a language, but that doesn't often work that well. Because well, if you're working in banking or insurance, and if you go to your boss and say, dude, I'm writing Scala since today, you are most likely to be fired and not like writing Scala code since next day. So we have a problem. But, well, you can also build yours yourself, but this can be, well, let's say quite problematic if you want to craft your own tools over and over again for the sake of certain project. The most practical solution for this is, for example, use, well, external libraries. There's one for Java ecosystem that's worth looking at. It's Waiver Java Slang, which has all those things already implemented and ready to use. Actually, not all of them, because there are much more ideas when it comes to functional exception handling. The most interesting one, I think, is monad error, because people started noticing that, well, you can handle exceptions in a new way. You can represent, well, let's say cases of absence with optionals. You can use tries, you can use either. But this is quite many ways to handle exceptions. So, as we developers think, why not introduce another layer of abstraction and abstract out those multiple new ways of handling exceptions? This is how monad error was born, which is a way of trying to like encapsulate the different ways, well, of exception handling. Which is, well, it's not present in waiver. I didn't see like many real use cases for this one, but it's kind of interesting to be aware that something like this exists. Also, so we are not switching language, we are probably not building it ourselves. We might use waiver because for me it's like a new guava this time. But also there is something like JCP, Java Community Process, which is super interesting because many ideas that are now in Java, for example, Java util tab, it's a kind of it was brought there as a result of community pressure. Because as we all know, Java, well, we know, Java is open to community, and community can have a real impact. And you could see this quite recently if you've been like following the case of Jigsaw. So, for example, I think 2 or 3 months ago, there was a lot of objection being made about the final specification of Jigsaw, and which ended up, well, in the whole Oracle just revising their approach to Jigsaw, and resulted in another delay of Java. So hopefully it will be released in a week. So if you know some Java champions, or if you are online, you can go to message board, you use mailing lists, and well, come up with your ideas. Maybe someday they will take more ideas back to Java, and we will not need to use external. So we are kind of going towards the end, and so let's sum up quickly everything that we've been talking about today. So exceptions in Java basically are fine. They are super fine, but in cases where you don't want people to recover from, when exception signifies a really exceptional situation. The first idea that we can use for exception handling, well, for example from Scala, is a try that allows us to represent computations that can result in exceptions. Sometimes it's also worth to remember that single cases, like cases of absence, can be modeled using optionals. It might be much easier, much more flexible for the other people that are consuming your APIs. And the final, like, ultimate solution is either that allows you to handle advanced scenarios where you can return error objects and where you don't really want to engage like the exception flow, just like in trial. Also, the last thing, consider having a look at waiver, X-Java slang library, because it gives you all those tools very well implemented and tested. And it's one of those 2 things that I always start Java projects with. The first thing is waiver, the second is London, and the third one is AssertJ for tests. So that would be all when it comes to those ideas they wanted to show you today. Obviously, they all have their own, well, there are different situations occur. Whenever you want to use one or not, it all depends on the context. There are no silver bullets. But still, I hope there are some ideas that you can, well, at least consider or think about and consider to implement or not in your project. So I hope it helps to broaden your horizons a bit. So thank you very much, and we have a lot of time for questions.
Just motivated to questions. I have 2 presents. So one actually is sorry, I forgot to put it in. So it's 2 amazing. You should close this one actually. New one. So if you have a question asked, Grzegorz will present it for you.
Have you ever been playing with try either, and do you have any like bad experience with that? Okay.
Yes, I use it every day in my work because I actually
Sorry, I didn't hear you, but microphone is coming to you.
It's open? Ah, it doesn't work. It doesn't work? No. So you should speak louder just, because it doesn't work. Sorry guys.
Okay, can you repeat?
Yeah, I'm using either and try every day in my day-to-day work, and I can do that because I'm working in Scala.
Okay, this is the best way, but as I told you, it's not always the option, because if you are working in Java, well, for example, we've been recently, since 1 year, I've been writing in Kotlin, but we tried to encourage our client to go for Scala, but it was a no-go because Scala developers are expensive and the hype for Scala is not that high as it used to be. And well, from my experience, it's quite hard to convince our corporate telco clients to go Scala. But some way we managed to convince them to go with Kotlin. Well, they bought it because they realized that Java developers can be productive in Kotlin in over just few hours of playing with it. So obviously, if you use Scala, you already know the benefits of using those tools.
Oops, I have quite real case. You know the situation when you have a lot of sequence functions or just commands, so you call one, the next one, next one, and on a really basic level, you have return null, and you up it and check on null, and if it's null, return null, and up, and quite often people just throw exception on the basic level because you check the whole line of the, like, let's assume it's 10 subcalls, so it's much easier to throw exception on the upper layer and return null.
Andrei just told me about a very interesting case. Well, it's a corner case. Sometimes where you have like a very spaghetti code, very deeply nested. Sometimes people don't want to try to go for every layer. Sometimes this is where you want to use, for example, exception for driving the whole process. Actually, we've been using this approach quite recently. Our company Talk in Poland, we created a tool for graphical user interface for Apache Flink. And I know that guys there were playing with string expression language a lot. And they wanted to add some additional functionality to it. But it was super problematic because they noticed that the implementation is so complex, so deeply nested, there was no way of pretty much just redesigning the whole Spring implementation. So the only way to go there was actually throw an exception. And well, it's not perfect, obviously, but in this case it worked, and it was still this is a corner case where all exceptions are fine.
Okay, I have a question. Why do you think that making an exception handling optional makes your code more predictable? Like in this Go example, when you have, for instance, you try to open a file and you can fail, but you can completely ignore the result. Do not write this check for the error. You just go on to whatever you were about to do with the file, which is not open. So. How is this predictable? I'm not sure. I agree that using exceptions is a bad thing, and Java does that a lot. Like Joshua Bloch, all those guys wrote years ago that you should not build your logic on exceptions. And people still do it like in the Spring data. For some reason they don't just for null when you have no results. Even the null would be better, right? I mean, you hate null probably, but it would be better than null on exception or whatever. But in the case of predictability, when Java forces you to handle an exception, or if you don't do it, you just exit your method, and whatever you were about to do is not going to happen. And that's the predictability. It's not going to happen if error happens. So isn't this actually more predictable than
well, check exceptions in kind of different situations. The thing I've been talking about earlier, it's more about runtime exceptions that can happen somewhere earlier. And with runtime exceptions, whenever you use Go's approach, you have only one single exit point where errors can be emitted. And if you look there, it's fine. Okay. If you skip, as you said, if you skip, it's a problem anyway. Okay, so you need to use that responsibly. Okay, if you get the right tools and use them wrong, you're in trouble. You don't benefit from that. But if you, well, the other way, if you use exceptions in Java, I think it was also like the Joshua Bloch's idea. They are good, they work fine as long as you catch them on the spot. If you catch them on the spot after they happen and just post them, it's fine. But if you, well, imagine you are working with code that, let's say, has bad documentation and throws a lot of runtime exceptions somewhere inside. And it becomes a problem, because, well, you can't be prepared for everything at once. But if you had only single like possible exit pointers in Go, well, you have no other way but just be prepared for that. Well, you can skip that, but that's irresponsible. So, well, the problem is about runtime exceptions more than checked exceptions. Checked exceptions force you to handle this. And actually, the idea of checked exceptions is very similar to try and to using types for representing like the whole the computational context of handling exceptions. Because when you return try or either, you are forced to handle exception. Okay, just like in check with checked exception. It's a good and a bad thing in some context. Okay, because there's a lot of many people don't like checked exceptions because if you abuse them, if you abuse this like checked exception safety, you end up with unmaintainable and unrefactorable spaghetti code. Okay, if you have like try checks spread over multiple classes and layers. So, well, this is another thing because, well, if you don't like checked exceptions, try and either will not, well, you won't be happy too because, well, again, if you have try and either and other stuff, and you still want to propagate, let's say, those propagators exceptions further, you still want to like pretty much it would change all your return type, all your type that you use over different methods. You still propagate tries and either. So instead of like multiple try catches, you propagate just different type, and this can be problematic in certain situations. So again, this is just a tool that you can use in situations where you think it's suitable. Obviously, use this responsible. It's not a solution that will work always. This is just an idea that you can implement and help you. I try to use this as much as possible because it simplifies a lot of stuff, but it's not always possible. Sometimes you just look at this and see, well, maybe it's just easier to leave that exception in there. So it's all up to, like, I would say that the best practice here to use is the common sense. Okay, t-shirt is yours.
I'm just now studying a whole work about static typing. When you told that it's good, I remember my experience with parsing XMLs. And well, there are lots of types that can be created because every tag can be of its own type. So it just came to my mind unit testing this shit. Well, it's just a side note. You wanted to limit the instantiation of variants like try and either, right? And like, why do you think it's bad to like, not just put a docstring that suggests you not extend them, but rather limiting this extension by the means of language?
Because my experience with like going, from dynamic type languages to static, I mean, I'm this kind of guy that likes to have the safety that well, types give. Okay, even if this means I need to write more code, even if it's sometimes harder to test, even sometimes when I get really irritated when I need to like, let's say, handle a case where I know that there won't be any exception, but let's say the strong static typing forces me to handle this in a certain way. Of course, it is annoying for me in most cases, but long term, I appreciate the safety it gives me. Obviously, here we could discuss basically how we can design statically typed languages so they are elastic enough to handle such situations. But in Java, it won't be I don't think we will have this discussion anymore because of the backwards compatibility and impossibility of introducing such solutions. Actually, I was on JUGLviv recently, and the cool thing about JUGLviv conference is that it's not a normal conference, it's an unconference, and there were no normal talks, but all talks were replaced with like discussion panels. So, for example, there was one discussion panel about future Java, functional Java, and there was a very cool discussion about like possible ways of developing statically typed languages so that they are not that painful when it comes to like certain situations. But yeah, there are many ideas that have been implemented there, but for Java, well, I just prefer sometimes to write more code, sometimes a little bit more boilerplate, but because when I, for example, when I tried TypeScript recently, I remember that when we were playing with this, in TypeScript there's a possibility of like just ignore type safety for some problems. So whenever we had problems, those were those parts of the code when we decided to just write in a dynamic manner. Don't use type safety that TypeScript provides. So this is basically how my approach to this. I know it's painful sometimes, but
I just come from Python world.
okay, you have a t-shirt. So?
Nobody has a question. I want to ask a question that's not exactly on the subject. Like, why would you use Kotlin? Because that's, I think, is the only JVM language that's good for nothing, in my opinion. Like, you have Java, of course, then you have Scala if you're smart enough to use it. There's, of course, Scala that gives you all the perks. And then you have Clojure if you want to go functional. And then you have Groovy if you want to make things simpler and have a syntactic sugar. And it's basically probably you could use Kotlin for the same reason that Groovy is older. So it's more mature. And we have also this Xtext extent that Eclipse uses in the Xtext. I don't know if you've seen the same. It's a way Eclipse is a framework to build DSLs in which the Eclipse generates to the IDE with the code completion and etc. So they use this with another JVM language. You probably know what I call it. It's called Xtemp. So it has a purpose. I'm like, why would you take the Kotlin over Groovy?
Okay, so let me ask you a short question. You think that Kotlin is unusable, basically, yes?
Not really. I never tried it, actually. I just don't know what would be the reason that would require me to try yet another JVM language. It's basically doing, as I understand, it's doing the same as Groovy.
It's not doing the same as Groovy. When the question is, I don't know if you heard everything, but the question was basically on the Kotlin and its place in the ecosystem. I've been working with Kotlin full time since 1 year, and I think at the beginning I was skeptical, but it had some interesting features, but I was more skeptical as I didn't consider this like a first-class citizen language. But now I changed my mind because there was a big black hole in the Java ecosystem. We had Java that still has carrying out all the demons that enforce certain design decisions because of backwards compatibility, and we have Scala on the other way. Okay, and people, when it comes to like pure like core Java people, they were often like against Scala because it's like there was OOP versus functional war, and Kotlin was a language something in between. It's not a Java++, it's more like Scala minus minus. It's much easier to use than Scala. If you know Java, you can spend just a few hours on Kotlin and benefit from it. It doesn't have all those problems that can't be fixed in Java because of the backwards compatibility contract. And it really much simplifies a lot of stuff that could be done in Java. Additionally, the interoperability between Kotlin and Java is super good. So, this is what convinces business too. Because if you go, Scala is not that easy compatible with Java, but Kotlin shares, not only is compatible with the language itself, but also is fully compatible with the whole stack of frameworks and stuff. You can simply use it with Kotlin. So
Isn't Groovy the same? It's also compatible with Java. It also allows you to do all the same.
no, I've been writing Groovy code for some time, and the experience wasn't that that nice as with Kotlin. And I remember that in order to make Groovy like usable, you need to start with compile static and type checked annotations. This is where the language became usable, because before we had everything dynamic and it was slightly problematic. The idea is, of course, marketing. Also, JetBrains pumps a lot of money into Kotlin promotion, and this is why it catches. Personally, I think that I enjoyed writing in Groovy, but Kotlin has bigger potential, I think, in the long term now. Let's see what happens in a few years from now, because now we know it's starting. The hype might just go down anytime.
It's
But
basically Groovy done right.
yes, I think it's kind of, yeah. It's like the best parts taken from Java, Scala, and Groovy in an easy way. However, I don't like the approach, one approach, because sometimes Kotlin is, well, on the other hand, it's implements, like, for example, functional ideas, but mixes it with ideas from Java. So sometimes we still end up with if-else, try-catch, help. So Kotlin, for example, has its own way for type safety, null safety, but it doesn't really use like some traditional optionals, tries, iders, and other stuff, but it has its own way for doing that. So that was quite an off-topic. I hope it helps. So, do you have any other questions? I guess no. So, thank you very much.
Ще таке на прощання, якщо ви маєте якісь побажання на наступні зустрічі, ну там теми, спікери чи щось там у дусі, пишіть на групі або в телеграмі, що привезіть такого-то дядька, або давайте говоримо таку штуку. Це набагато легше. У нас інколи є спікер, він каже, а про що ви хочете послухати? Ми кажемо, та давай сьогодні послухаємо про functional exception, тому що я конкретно не знаю, але можливо для вас якісь інші теми цікаві. Тому краще пишіть, що вам цікаво, і тоді ми будемо більше від вас адаптуватися. Все, дякую, бувайте здорові, радий вас побачити.